In this video, I wanted to show you how to use Microsoft Excel or a similar data program to do a lot of the stuff we've done from our first couple chapters of work. Stuff such as finding the mean or median, quartiles, standard deviation, and so forth. And we've done it all by hand just to sort of try to explore how these things work and kind of the concept of everything. But a lot of times doing a lot of this number crunching might be quite tedious, and especially when we're working with large data sets with thousands of data entries might be less practical, or take days to even calculate them all by hand. So luckily Excel makes that all very easy, and I wanted to show you how to do that. So let's just kind of go through our lecture, the whole lecture series in order, and kind of practice doing a few things with Excel. And if you'd like to try this yourself, the Excel sheet is also provided at the top with my lecture notes. It should be called Student Data, Chapters 1 and 2. Looks like I cannot open it. What was it called? Sorry, bear with me 1 second. Excel practice chapters 1 and 2. But yeah, basically it has the data from our 10 students that we did all of our analysis for, and it also has the data for Amanda's 7 quizzes. So if we want to try to create a lot of the things we've been working with, we can do that right here. So let's start off with graphs and plots. Excel can make bar graphs, histograms, it can make pie charts, and so forth quite easily by literally the click of a button. So let's say we wanted to create a histogram that was resembling the one we did for our student's age. Basically what you want to do is obviously have all the data entered into Excel already, which I've provided just to make it a little bit easier. But basically we're just going to select the 10 ages of our students. And then if you go into insert, there should be a whole bunch of different types of graphs. And this is something that I recommend you guys just play around with on your own. But if we look at this, we can see stuff such as histogram as one of the main options. And actually also notice there's a box and whisker plot, which is the same thing that our book just calls a box plot, but sometimes they're called box and whiskers. But anyways, let's go ahead and make a histogram, see how it compares to the one we created from scratch by hand. So if we look at this, notice that it actually makes 3 bars, and the way that it does it, notice it kind of has an automatic grouping of the various ages, which sometimes might be very intuitive and sometimes it might not make sense. How we did it every 3 or 4 years, but it looks like they've used almost 10 years as their margin for their boxes. And this can all be customized in Excel with just a little bit of practice. If you just click on the data, or right click it rather, and you click Format Axis, it will allow you to customize this. Sorry, I know it's coming off as a little bit small in the recording. But notice what it refers to it as is the bin width and the number of bins. So basically, let's say that you wanted to have 5 bins or 6 bins. It will kind of automatically adjust it for that desired specification. You need to hit enter and it will go ahead and do that. Again, these margins can be a little bit strange, so I probably in this case would use a bin width like maybe of 4, just as kind of a way of seeing it, and that will make it so we can see it a little bit more clearly. And actually, if you look at this is exactly the same histogram that we made over here. We have students between the ages of 18 and 22, to which there were 7. And then we had students between the age of 22 and 25. And notice that they actually use a slightly different, they use interval notation, inclusive versus exclusive, to do this as well. I don't think that's worth getting into right now in differentiation of this. So we won't really worry about it. But anyways, kind of, you can recreate these plots and kind of check to see did yours come out correctly. And it's like, and you might wonder, well, is there a better way of doing it? You could always play around with those formats. Like let's say we wanted to make a bin width of 2, just see how it would look instead. It can kind of change the way the data is displayed. And one way might seem a little bit more appropriate than another, depending on your data.